I was watching a video put together by some young folks in Florida about cutting up some paper so that they could prove the formula for pi times the radius squared for finding the area of a circle. And it got me to thinking, so, well, let's just take a look at a couple of things here and see what would happen if I took a circle and I wanted to prove pi times the radius squared. Well, we know that you can find the area of something if you know its length and its width. So I decided, well, what if I were to cut up this same size circle? We'll just say that the diameter here is 2. If I were to cut up that circle, and by the way, if the diameter is 2, I can certainly calculate the circumference of that. So I would know the radius to be 1. And my circumference here would be 6.28 if you want to stop it after decimal places. So if I were to cut this into 4 pieces and arrange those 4 pieces like this, it's no longer a circle, but these pieces have started going more like a rectangle. And if I were to cut that same size circle into 8 pieces and arrange them like this, now those 8 pieces are becoming more like a rectangle, and I can calculate that. And I know that this length right here is 1, and I can know what this length right here is, although it's curved. I can know what that is because it's just half of the circumference of the circle, and I can calculate that. Well, it turns out that if I continue going in this direction and I go 16 and I take the same size circle and I cut it up into 16 equal slices like this and I arrange it like this, I'm getting more and more like a rectangle. And we know that if we have a rectangle, we can find the area of the rectangle by just multiplying the length times the width. Well, if I take that same circle and I cut it up into 32 pieces and I arrange them like this, I still know that this is my radius of 1, this length right here is 1, and I can still know that this is half of my circumference. Well, if I take that same circle and I cut it up into 64, it looks like this. And I'm getting closer and closer to a rectangle. Not a perfect rectangle, and if we zoomed in real tight, you would see that there's still a little bit of a curve here. We'll never get rid of that curve, but we keep getting it smaller and smaller. And so if I take that same circle and I cut it up into 512 pieces, it would look something like this. And this is 512 pieces, and we're zooming in way in. And so if I were to take these 512 pieces and stack them along like this, then I become more and more like a rectangle, and I can calculate the length times the width, and I could find the area of that. And so let's zoom in real close here. What I've done is, that doesn't really look like it's much of a curve, but I've drawn a straight line from this point to this point, and if I zoom in real close, you can see that this is my straight line and this is my curve. Go like this. And go like this. Just zoom in here, and you'll see that the straight line and the curved line do come together here. So anyway, the whole point of that was to just show that I'm not a perfect rectangle here. This is not a perfect rectangle. It's just a circle, the same size circle, cut up into 512 parts and then stacked like this, and it becomes more and more rectangular. So if you liked what you saw and you have any other questions, you can always reach me by contacting me at alanmorris@yahoo.com.